All right, so let's look at number 1. Can I get a volunteer to read that? Where it says the graph below.
The graph below shows a relationship between gasoline price and the number of people riding the bus over an 18-month period.
Thank you, Leslie. So this graph right here, because the copy is kind of rough, but this is gas price in dollars, and on the y-axis it says bus passengers thousands, and that's a 2, a 4, a 6, an 8, and that's in thousands. And these are gas prices in dollars. So this is 1, 2, 3, 4, and 5. So, according to the scatter plot, how does an increase in gasoline prices affect the number of bus passengers? What happens as the gasoline prices go up? What's increasing? Down here where gas is $1, I don't have $1 a gallon. I really don't have that many passengers. But as the gas price goes up to $2, I have about 4,000 passengers. And when it goes up to $3, I have between 4,000 and 6,000. And as it goes up to $4, I have what? What's going on when the gasoline price increase? How does that affect the number of bus passengers? Are the number of bus passengers going up or down? It's going up. So it asks, how does an increase in gasoline prices affect the number of bus passengers? You will write, as gasoline prices increase, the number of bus passengers increases. So, let's look at our anchor chart real quick. If I have an increase, as one of my variables increase, so as my gas prices increase, so does my bus passenger number. What type of correlation? Is this positive, negative, or no correlation? It's positive. Positive just means as one variable goes up, the other one goes up. So as my price of the gas goes up, more people are going to ride the bus. That just makes sense, right? Ain't nobody trying to pay $4 a gallon for no gas. I just catch the bus, you know. But when gas is $1, yeah, you'll pay $1 for a gallon and drive all over the place. So I just want you to write this as positive correlation. That's 2 R's, 1 L. It says, in a month in which gas prices are $2.75 per gallon, approximately how many passengers should the bus company expect? So if we look at our graph, $2.75 would be right here, right? Like right before $3. So then we'll go up and we'll make a horizontal line here just so we can kind of see. About how many bus passengers should we expect when gas is $2.75 a gallon? That line is hitting between 2,000 and 4,000. About how many bus passengers do you think? Where did I hit my y-axis?
4,000.
Right, yeah, right here, about halfway between 2,000 and 4,000. You know, that's where the data points start going. So, yeah, I think you're right, Leslie. Let's go with 4,000 because there's more data points up here closer to 4. So, we're going to say all we did was go on the x-axis to where gas would be about 275. You remember yesterday when we were plotting the points, I'm like, it doesn't have to be exact, but it has to be, definitely before 3, because 275 would become before 3. You're making predictions, you're making estimates, you're making good guesses. We're not doing exact calculations just yet, okay? So we know that we can probably estimate that gas were $2.75 a gallon, we'd have about 4,000 roughly in bus passengers, because that's where the data points start occurring. Does anyone have any questions about that one, or how I came up with that figure, or what positive correlation might be? There's no silly questions at this point, okay, guys? Let's look at number 2. It says, which of these scatter plots shows a negative correlation? What does negative correlation mean?
It decreases.
Right. As one increases, the other decreases. So as my distance that I drive goes up, the amount of gas in my car goes down. That's a negative relationship. So which one or negative correlation? Which one would show negative correlation? How many people say C? Because how many people say C?
Well,
Yeah.
let me think.
You wanna think. Well, Gabby wants to think about it, and that's okay. Remember, look at your anchor chart to help you if you need.
Okay, bye.
Which one do you think it is, Gabby?
I think it's a 2.
You're right. This is negative correlation. It's C. What is A?
Oh, no correlation.
Yeah, that's no correlation. What is B? Positive, right. This is negative. And what is D? No correlation. Even though it looks like a rainbow and it's cute, it's still no correlation. We'll do number 3 together, and I'll leave 4 and 5 for you. Okay? So it says, Tina records the ages and weights of 12 children in her neighborhood. If she records this data in a scatter plot, what type of relationship will she most likely see? So, remember yesterday when we took our notes and I gave the example? It said, we had the heights and weights of the children in the classroom, and we saw there was positive correlation. Did we discuss why that the height and weight of a child would have a positive correlation versus the height and weight of an adult? Do children get to eat do they get to get their own food? No, adults have to give it for them. So kids don't have access. Well, they do. Some of them do. But by and large, kids generally don't get to decide what they eat or when they eat. Their parents do, or their school schedule tells them what time it is. So kids tend to be proportional as far as their height and weight. The taller kids weigh more simply because they're taller, not because they're fatter. But when it comes to adults who can get their own food and eat whenever we want, the height and weight thing doesn't necessarily have correlation, because you can have tall adults who are overweight, and you have short adults who are overweight too. So height and weight are not really correlated with adults, but with children it is. So on number 3, is this going to be a positive, negative, or no correlation? It's going to be a positive correlation. I don't know why they gave us that graph. We don't have to draw anything. You just have to talk about, a lot of this is just kind of thinking about things, and children, again, obviously you're going to have kids that are overweight and stuff like that, but the population of those kids are going to be a lot smaller than if you're talking about adults. The same thing yesterday when we used the example of the African elephants about their height and weight. As height goes up, their weight goes up, because elephants aren't, eating Takis or ice cream or things like, things that are bad for them. They only eat when they're hungry, and they're only eating the natural food that was created for them to eat. So also with an animal, their height and weight is more likely to be in proportion, where the taller animals are weighing more simply because they're bigger, not because they're bigger around. Do y'all kind of understand what I'm saying when we talk about that? So you, just as we go through this unit, understand there's a positive correlation between height and weight, okay? I'm going to leave you to answer 4 and 5 on your own. You can ask around, make sure, the classroom, check with other people, see if you got the right thing. Make sure your first and last name is on it and today's date. And once you're done with this, you'll need to log into Imagine Math and do the STAR review for 8th grade math, okay? We're going to start keeping up with that. So I'm going to be at the back of the room, and if you have questions, I'll be happy to help you. All right. Yes.